So, hallo zusammen. Oh, this talk is going to be in English. Sorry. Whew, almost missed that. So, English talk. There you go. So the goal today is to start with the Java 8 code base and then update it to 14 and show you how many things are in there, how many new things came after Java 8. And the important part there is that this is not a tutorial. I'm not here to explain you how all of these features work. Quite the opposite. I'm just going to slap you with features for like 40 minutes now, and hopefully giving the impression that there are so many things in there that an update is really worth it. And yet, this is not a complete list. If we have time, we'll see that later. There are a bunch of links here. If you go to slides.codefx.org, then you can see the talk on the top right side, and you can follow along. And then there are also links to this repository that I'm working on right now, and another repository where all the features are explained in more detail. So let's quickly talk about Java 8. Now it's like 6 years old, and it was released by Oracle support by Oracle ended free support last year, and you can pay Oracle and other companies for commercial support, but there will be free support by Red Hat or the community at large under the guidance of Red Hat until at least 2023. And there are many very different options for commercial support as well. And it's a good release to be on, right? It has a solid feature set. Performance is good. It's quite stable, and even though it still sees occasional backports, so really it's a good release to be on. But you can tell that it's 6 years old by now. There are many new language features that, of course, can't be backported. Many new APIs that could not be backported. JVM features and improved performance in specific cases. All of that is something that that cannot be backported to Java 8 and that you're missing out on if you're still using it. So now I want to show you what all these things are, and for that we're going to code a lot. And I just told Hendrik that I found out a minute before the talk started that I can actually log out of my operating system by just one key press. So I had to recreate all of this very quickly. So let's see whether this all works. So what are we doing here? So first of all, I'm going to show you the project quickly, but let's quickly switch to the correct Java version. SDKman, I recommend using SDKman for that. So let's switch to Java 8. Great. Now if we ask Maven which version it's running on, we see this is the Maven version and we're running Java 8. So that's good. Let's quickly go through the project. Basically what it does is it takes as input a bunch of blog posts in the format that is common when you write them in Markdown, which has a little front. Let's see, has a little front matter here, and then it has a bunch of. And then the text is down here, right? And the front matter is just a bunch of key value pairs, basically. And what we want to do is we take these blog posts as input, and then as output we get basically recommendations. Consider you read this one blog post, which 3 other blog posts do you want to read maybe? And the part of the program is basically just reading through all these files and parsing them into internal data structures. So we have this in this package here, article. You can see that there's an article file here, which amazing. Wait, let me quickly fix that. I guess the problem lies somewhere here. Let's see. Maybe just it has to reindex IntelliJ, although actually it doesn't look like it. No, that was what I was afraid of. What could that's not good. Oh, I'm blanking here. I could show you the classes still, and I have no idea how we're going to fix how we're going to deal with the compile errors for now. But let's just walk through the project anyway. Maybe we just have to ignore everything that's read and go ahead and do this the hard way. So as I mentioned, this package here contains the classes that correspond to this to a single article here. So you can see it has a tag class, which contains a single tag here, which is what topic this article is about. You have a title here, which captures the title. You have a description, which captures the description, and so on and so forth. These are these classes. And if you look at the tag class, for example, we'll see that. Yeah. Wait a second. Ja, mal, aber später. home office, right? That was my daughter. We see that, for example, oh, that's why. I get it now.
Ja, ich wollte gerade fragen, ob du im falschen Branch bist, weil Records gehen nicht mit 8. Ja.
Helps to be on the right branch. Whew, fix that. So let's have a look at the slug then. A slug is really just a string. And the slug would be the URL part, this one. That's the rest at the end of the URL. And then we have a title. Once again, that's really just a wrapper around a string, and so on and so forth. That's what lives in this package. And then we have the genealogist package, which declares an API. This API is used to actually compare and basically find relations between articles. That's why I use the term genealogist, Anforschung in German. So basically looks for relationships. The service really just takes in a collection of articles and then creates a genealogist, and then genealogist takes in 2 articles and infers some kind of relation. And we're going to see implementations of this in a second. And then we can go on. This is just, as I said, the API, and then in genealogy here, this is where we put all of these things together, where we really check, where we basically create a bunch of genealogists, or basically we use a bunch of genealogists. We get that in the constructor, and then also a bunch of articles. And then we do what you would expect. Basically, you have a loop. It's a stream, but you can think of it as a loop that goes over all the genealogists. They compare all the articles. And in the end, you aggregate all of that data, and you put that into the recommendation pipeline. And the recommender takes in a bunch of relations. And how many recommendations do you want to have per article? And out come the recommendations. And then there's a main class which puts this all together. So where do the genealogists come from? We didn't see them yet. This is where the second project comes in. This is just the implementations for the genealogist. I implemented 2. The one is really silly. It just looks as the letters of the title, and 2 articles are more identified as being closely related if they share a lot of the same letters in the title, which is silly, but works surprisingly well, actually. And this one is a little bit more sophisticated. It does a similar thing based on tags. So it takes 2 articles tags and then checks how large is the overlap. And then the larger the overlap, the more related the articles are. And these are registered as services. You can use services without the module system, right? Since Java 6, that would be this then. So this is how the 2 modules, the 2 sub-projects interact with one another. And we can now run this. There we go. Great. Yeah, I know what that one is. Okay. So now we're building this. Then we run it 10 times, so we can get a better estimation of the average runtime. Now, the runtime down here, that's not a good performance measurement, right? You can't just run the application 10 times and be like, well, that's the performance. It's just a very coarse estimation, and we can see later how that changes. What we can see, though, that we ran it 10 times with 10 different process IDs. This is basically the output of each execution, the process ID and the major version. Maybe someone in operations thought that was a good idea. And then this down here is a small script that I wrote that I just executed, which computes the average runtime and shows us some code statistics. We start with 1,650 lines. That's kind of important because we're going to see how that number drop fast. One thing I want to show, right, it's the output. That would be in recommendations.json. This is what the output looks like, straightforward. Article with that title has these 3 articles recommended. Okay, good. That's where we start. Now let's move to Java 9. So first of all, we use SDKman to update to Java 9 here. And when we're done with that, we have to tell IntelliJ. No, sorry, that was me. We have to tell IntelliJ about it. This should be project default. And here we switch to 9. You can auto-import this, and then it should happen on its own. But I promised with that, so let's do it this way. So if you ever heard that the Java 9 update is hard, it doesn't have to be. This won't work. Well, there we go. Let's see, this works already. So we just updated to Java 9, and that wasn't hard, right? So if you have a project with almost no code and no dependencies, then it's really easy to update it to Java 9. It gets a little bit tougher after that, but it's not impossible either. Okay, I want to show you the module system, but coding that takes a little while. It's easier to just show you. So the first thing I did was to make this work with the module system. And for that, I created 2 modules, right, for the 2 subprojects. And the first one is this one, the genealogy one, that requires one Java project, sorry, one Java module, and exports 2 packages with the API and uses a service. And then the module requires the first one and nothing else, and provides that service with the one implementation with the tag genealogist service. So an interesting thing about this is that, these are there are 4 packages here, right? 5 if you include the top level package. So there are 5 packages here. And for example, recommender, that's a public class. So usually from outside of that module, or rather from outside of that subproject, from outside of that jar, you could use recommender because it's a public class, so everybody can use it. Now with the modules, we can't anymore on purpose because this was never intended to be part of the public API. So with the module system, I now actually encapsulated 2 things, or 2 packages, 3 actually, the top level one as well, which I never considered to be part of the public API, and they're now strongly encapsulated at compile and runtime. So that's a benefit, I'd say. But the Java 9 is much more than the module system. Let's have a look at arrays as list, for example. As you can see, a full text search for arrays as lists delivers a bunch of hits. And they're all very much the same, basically. I want to have a couple of values and need them in a list, so this is the easiest to create them. But arrays as list is weird. The thing you get back is it's halfway immutable because you cannot add or remove, but you can set things at indices. And then also you have to know that it's on arrays and not on list, and that's weird. So in Java 9, we can use the collection factory methods. And what you could essentially really do is you could go through all of these that I just searched, right, and replace arrays as list everywhere. We don't only have list.off, we also have map.off. So here, for example, I create a new hash map and put 2 values in. This is in a test. So I need these 2 relations to make the test work. And without Java, before Java 9, there was really no good way to do this. With Java 9, we can say I want to have a map of, well, these 2 thingies here. And there we are. So now we can, very easily create that map. And when you look at this, you realize, wait, we just need that once, like down there. Can we just inline that variable? And yes, you can. And if we've done that, we might realize, wait, the entire constructor was just there to create this one field. Can't we remove that as well? And yes, we can. And this will happen quite often, that you have situations where this does actually happen quite often, where you have situations where you have a static field often, like a static final field, which is a collection with just a couple of values, but you can't create the collection easily in one simple expression or one simple statement. So you have to have a static initializer just to fill that map or to fill that set or list. And with Java 8, that goes away. You can just, with Java 9, that goes away. You can just do it like this. And this also happens quite frequently in the scope base. Right. Here, for example, we have these values where you put in null in the map. This different place in the code base, right? I have a hash map, and then I put in null. This will not work with collection factories because they can't accept null. So that's important to keep in mind. Now, something else that Java 9 gave us, which is really cool, is take while and drop while for streams. So let's have a look at this. What does this method do? It takes in a list of string, which is the lines in a markdown file. So look at a markdown file. One should be down there. Have a look at this one. So each line is a single entry in that stream. Now we want to have just these lines. How do you get them? Well, the way we do it here is to basically look for the first 3 dashes and start with our collection, and then go to the last 3 dashes and then stop. This is what this does. Did the front method start? And well, if we found the separator, then yes. And if we found the separator and already started, then we're done. And this is a little back and forth. But this is really much more complicated than it has to, because if you think about it, all we're doing is we want to say, look, we have this collection here. Let's turn it into a stream. And then basically what we want to do is we want to do something like skip. When you say skip 5, you skip the first 5 entries. But that doesn't work because we need something of a predicate here. And we can do that with drop while. So drop while is basically skip, but I'll tell you when to stop skipping. So we're going to drop lines while the line, don't need that either. So we're going to drop while the line does not equal the separator. So everything that's before the first separator gets dropped now. Well, now we don't want to have the separator either, so we skip that line. And then we do the opposite. Now we take strings out of the stream while we don't hit the second one. So that's the same predicate, but now we take while. And now we're taking more lines out of the stream while we don't hit the second separator, and then we're done. Now we can actually we can just do this right in IntelliJ. Right, collect the list. We can return this, and then down here with extract content, we can basically do the same. Extract content does a similar thing. Looks for the first, and then the second, and then starts here. And the cool thing, and I don't want to walk through this right now, is this now operates on streams, which means it's entirely lazy. And if we can pull this entire eager reading of the file out and make sure that the entire file is just read once and only when it's actually needed, or not eagerly beforehand. So that's a pretty cool improvement as well. Now let's have a look at optional improvements. I'm sure you've done this in Java 8. You got an optional back, and then you check whether it's present, and then you do something. Well, the reason why you do it with an if and else here is because we also have an else branch. And what you would have preferred to do in Java 8 is this. If it's present, then take the file, and then do whatever you want to do with the file, which is this. And, well, otherwise, well, now we're screwed. But in Java 9, we got if present or else. So we can just say, OK, in the else branch, just do this. Now, remember, in the log messages in the beginning, the Java version of the process ID, that's what this part of the code does here. And as you might or might not know, getting the process ID is not that easy on Java 8. So before. And there are several methods. And I looked at Stack Overflow to get an overview of how many there are. And there are at least these 4. And I decided, because none of them are guaranteed to work across all operating systems and JVMs, I did what a real-life code base may have to do. I just used all of them, and then basically I chained them. So each of them gives me back an option of long, meaning, well, if it worked, here's your process ID. If it didn't, here's an empty optional. So what we want to do is we want to try the first one, and if it's present, we're done. Or and if it's not, we want to try the second one. And if that one is present, we're done. This is really long and repetitive code, and it really hides what's really going on. Because in Java 8, there's no way to recover from an empty optional into a new optional, right? So basically what you need something is like what flatmap is to map. That's what we need for or else. And that's what or is for. So now we can say, use the first one, or if that didn't work, then execute this one. And IntelliJ already tells us this is a method reference. OK, so we can keep doing that. So try the first one, or this one, or the last one. Where is it? Here. Oh, yeah, there it is. And then we just return this. And I have these cases quite frequently. I like optional. I really try to use it everywhere where something could not be there. So I happen to often be in the case where there are a bunch of things that I want to basically have fallbacks for. Try the first thing, and if that isn't there, try the second thing. And with or, this becomes as easy as it should have been in the first place. But it gets better, because in Java 9, we don't actually have to do the process ID dance anymore. Finally, Java got some rocket science, where I can just say process handle, current, and now look at this, process ID. Wow, that means all of this down here out the window. So that's a good one. And since we're here, the same is true for the Java version. So Also, you could just, what we do here, basically, we get the system property for the Java version, and then we try to parse it, and that may or may not work. There's a funny anecdote here about log4j1 failing to work on Java 9 because they tried to parse the string in a way that didn't work. They're not the only one, they're just the most well-known one. We can finally stop doing that. I can just be runtime, version. In this case, I'm looking for major. And there it is. This code goes away as well. So there's improvements for the new APIs that were introduced in newer Java features, newer Java releases, that really helped improve the overall usability of the JDK itself. Okay, there are a few more things that we can do, but as before, like with the module system, I'm not going to do them directly. So I'm just going to check out quickly. Let me see. There we go. I want to check out the version which has all Java 9 things in all its beauty. And then we can run the application again. One point I started implementing a Maven plugin, or look at implementing a Maven plugin that plays some music while I'm waiting for Maven build, but that actually doesn't work well because Java and MP3s are hard, apparently. Look, so first of all, runtime increased. As I said, these are not reliable performance measurements, but that's what I observed in real life as well. Runtime increased a bit, not by 20% in general, but in this case. But we lost about 100 lines of code. And I would argue that none of the lines we lost were really essential or important, and was not a big thing that we got rid of them. Okay, let's move to Java 10. Okay, I saw that people are raising their hands in the chat. Maybe I should react to that. I don't know the tool either. I don't know what raising your hand means. But if it's a question, I didn't see it. Where are we? Project. Java 10. That's that. Now, Java 10 is most well known for var. And we can argue whether var is how important var is and how much you should use it. But this method here gives a few really good examples where var really helps. So let's have a look at this line. Config is config create. So this type is not really telling us a whole lot, right? Oh. No, didn't. Okay. Did auto import, actually. Oh, right. That's the problem. Sorry. Other part of updating. It's so 3 parts to updating. It's command line, Maven, IntelliJ. I have to remember all 3 of these. Now we re-import, and now var should turn orange. Great. Okay. Same thing here. Genealogy is create genealogy. And recommender, I get it. There are quite a lot of cases where code is repetitive like that, where the class name is the variable name. And you could argue that maybe there's a better variable name here. But if you choose a better variable name here, you probably don't need to type even less. So that certain instances, surely var helps. What about these streams? Well, it could be a list, right? Could be a set. Now it was a stream, who knows? But the other thing is, it's a plural. It's most likely some kind of collection. But here we're already getting into more murky waters, where maybe it's not such a benefit to use var after all. But it's there, and it does help a lot. Down here as well. I'm not going to go through the entire code base and put var everywhere, because it takes a day. Then we had the collection factories earlier. They saw an improvement in Java 10. Let's have a look at this. What we're doing here is we're getting a map as input. And then we're storing it into a field. But I create for this to do, you need to create, or you should maybe create a defensive copy, because you don't want someone from outside to work on your map and change it under the hood, right? So you want to make a copy. This is a way to do it with weights. And then I also write some code that checks whether it contains no nulls, because I don't like nulls. So that's why I wrote this test as well. With Java 10, I'm going to probably screw up the version I'm working on for a couple more times. We can do copy of. And this does 3 things, basically. The first thing is where it creates the copy of the map that you put in. It also does the null checks, because the collection factories don't like null. And the third thing it does, which is kind of neat, is it checks whether the thing that I got was already one of these unmodifiable collection factories that map.off or map.copy.off return. And if it is, then copy.off just returns the same instance. So wait and wait might actually be the same instance. That's pretty cool because collections.unmodifiable ... they don't do that. If you nest them often enough, you will ask get on a list that was wrapped like 20 times, and then you will actually have 20 method calls down the stack until you reach the one at the bottom. Not a big thing usually, but it's a nice little improvement. Also, wherever you use toList, which is quite a lot, let's just search in Java. Here, for example, in many of these cases, the list that you get back, you don't want to modify it. And if you say to unmodifiable list now, then you get one of the lists back, or you get one of the types back that list.off uses as well. In hindsight, actually, it's a little bit annoying that we first got to list, and then 2 versions later we got to unmodifiable list. I would prefer it if toList returns something unmodifiable, and you would have to, do the extra work to get something modifiable back. But there we are. There were like 2 releases in between, so I guess that's fair enough. Another thing that was added was application class data sharing. And as before, I'm not going to walk you through all the details. I just want to show it to you. There's a script here, cds.sh. If you go through the code base, it also evolves over time because later Java version changed it. And what application class data sharing really does is it improves launch time of your application by reducing the amount of class loading work that the JVM has to do. And it does that with an archive. And this script walks you through how to create the archive and how to eventually use it. And if we've done all that, then we can, build the project again. And if you use it with and without class data sharing, you will see a slight difference in runtime. It really depends on your application, though. So actually, now the runtime got worse. Once again, no professional performance measurements here. And we dropped a few more lines, not many, like 20, but better than nothing. The character count reduced because of all the vars, but maybe character count is not the best way to measure code quality. Depends on your style, but generally speaking, I think it's not. Okay, let's move to Java 11. Let's see whether I can do all the 3 things I have to do. 1, 2. I usually give this presentation on a laptop. It's so much better to do it on my own machine. I never realized. Well, usually it's like 2 times before. I think I can stop switching these actually, but I don't want to try that on stream now. Or live, rather. Okay, I want to call your attention to 2 blog posts. So let's quickly have a look at the recommendations. Search? No? Hello? There it is. Okay, so this is an article, Code First Java 9 tutorial, and there are a bunch of recommendations here. So keep that in mind. Code First Java 9 tutorial, and see that under the recommendations, there's another title. There's some titles not there, and that's called Java 9 resources. Note that Java 9 resources is not recommended here. If we look at Java 9 resources, we'll see the other way around. It also doesn't recommend the tutorial, right? So apparently they're quite different, the talks, or at least they're not very similar. But that's not actually the case. Quite the opposite. They're very similar. So if we look at the markdown files, we see the tag here, which are Java and Java 9. And this one, and for the Code First tutorial, it's the same tags. And the way this works means that these two articles get 100% score because both of them share 100% of the other's tags. So that makes them quite similar. And if you would now look at the other actual recommendations that they got, like at the other posts here, they don't have the same amount of overlap. So what's going wrong here? Well, why doesn't this recommendation work? Let's have a look at tag class, which is in charge of parsing this. As this static factory method gets as input a line like this stuff, well, actually, I think with the parenthesis. It strips the parenthesis out, splits on the comma, trims the white space, makes sure it's not empty, and then creates tags from them. Now, as I'm sure some of you have already spotted, the problem is that these two spaces here are not actually the same kind of space. One of them is Unicode 2001 Odyssey in Space. That's the official name as far as I know, or as far as I'm concerned at least. And trim doesn't recognize that it's white space. Trim recognizes as white space what is Unicode 20 or below. And if you ask character.is white space, it would tell you, yes, both of these are white space. So the problem is that when putting these tags together here, we actually get one tag which has an almost white space in the beginning. That's not helpful, and that's weird behavior. And since Java 11, we can use strip here, which does the same thing as trim, but it works as character as white space does. And so it removes a couple of things that trim would not remove. So if we run this now, we will see that the recommendation is what we would expect. Let's go to recommendations. And here you see Java Now Resources recommends the tutorial and also the other way around. So strip, not trim, that's important. Going back to tag, that's also another cool thing here. See what we're doing here? We're filtering the non-empty tags. Now, first of all, we shouldn't use is empty, because is empty checks if we would trim the string, would it then be the empty string? But we shouldn't use trim, so we don't want to use is empty either. Well, we shouldn't. In many cases, you probably don't want to. So everywhere where you want to use strip, you should also use is blank, which means if we strip this string, would it then be empty? Oh, but what we're doing here is we're having a lambda, and the only reason why this is a lambda and not, say, a method reference is because, well, now it's the other way around, right? We want to have a negation here. This is a predicate, and it would be nice if you could just say .negate, but that's not how the Java compiler works. The compiler doesn't know what this method reference is supposed to be, so this doesn't work. But what we can do instead is, on predicate, we got a new static factory method which says not. And then this works. And I would argue, you know what? Let's just kick the predicate out. Let's make a static import. And then we say filter not is blank. I would say that's more readable. I think, not sure whether that's actually less code, but it surely is straightforward to read because it doesn't depend on a small exclamation mark. It clearly spells out not is blank. So I think that's actually considerable, a small but noteworthy improvement. This class is in charge of loading a configuration, and it deals with paths. And how do you create a path? You call paths.get. Not the worst thing in the world, but you actually have to know about it. Since Java 12, you can say path off. And then one more thing. Down here, we read the config somewhere. Create, read, config here. And what we're doing here is we call read all lines, which returns a list, but we need that as an array. For whatever reason, we need this as an array. So we turn the list into an array. Well, how do you do this? In this case, we say to array, and we create a string array of length 0. But wait, isn't that a waste of performance, right? You're creating an empty string array, sorry, just to immediately start filling with other elements that, and that definitely, well, most likely more than 0. So you create that empty string array that you're never going to need. Well, to properly do that, to know the length of this, you have to store it into a variable now, and then use the length here. So that's code, and it's somehow bloat. Also, it's unnecessary. As it turns out, on current JVMs, this is actually faster. But we shouldn't know this. So what we can do now, we can do the same thing that works for streams. We can just use array supply here. So reference, array constructor reference is the right term. We can use that one here. And this way, we don't have to bother whether it gets a 0 or the actual length or whatever. The JDK will keep track of that, and we'll do the right thing there. Okay, let's have a look and run this the final time on Java 11. How many lines did we have before? 1550 roundabout, and I think, yeah, we lost a couple few lines, so not a whole lot here. Still Java 11, that's the release most of you will probably be on. And so what we can now do, we can move to 12. But I'm just going to talk you through this because I have to get to 14. I don't want to skip 14. So in 12, there are a couple of small things in there. The biggest thing is switch expressions, which was first introduced as a preview feature. And the entire code base never switches. So unfortunately, I can't show you switch expressions, but they're pretty cool. Then the other part is that you have a T in collector. A T in collector is for stream. And what it means is you can use two other collectors and then combine their result. Say you have a stream of numbers and want to compute the average and the total. As the moment, you can have a collector that does either of those. With teeing, you can use teeing, use the first and the second collector, and later you provide a function that puts both of these values together. So that's really good. Complete with future got a little bit improved, and CDS archives as well. And let's instead go to Java 13, which is really mostly, besides a few other things, you can see the multi-line strings there. And I want to have a look at that together with you. At least let's have a look at the result, what this looks like. That would be this. So before this change, actually, you know what? Let me change out. Let me quickly check out the former version. This is what this was before. I'm creating JSON here. Why would I create JSON? Why not use a library? Well, it's just a very little bit of library. I mean, very little bit of code, right? I don't want to use a library for 10 lines of code. But also, then I can't show you text blocks. So there you go. So what we're doing here is we're creating the JSON blueprints, basically, that in the end we'll create these blocks. So you see we need some indentation here, which, of course, we use tabs for. Tabs, space, no spaces. And then, it goes over multiple lines and all that. And this is what it looks like in a regular string. Not too bad, not the end of the world, but not really comfortable to read either, particularly if you don't diligently use this here, but you just put all of them in the same line, right? They could be all the same line. This is, just as correct. But now it becomes really unreadable. And this is where multi-line strings come in. I would argue that this is a much more readable approach. Now you can clearly see what this block is supposed to look like. So that's pretty good. Now, finally, the coup de grace. Let's move to Java 14 and records. Command line, Maven, re-import, project version. I think I don't need to do this actually with the project version. Next time I'm going to just leave it at 14. We talked about these classes, right? Like a tag. A tag is just a wrapper around a string, but it has to have the field, the constructor, an accessor, which you would usually call a getter, but I stopped using the get word ages ago because I don't like it, equals hash code. You can generate all of this in your IDE, but then you add a field, and then you either regenerate it, or you have to edit manually. And you know what? All of that is kind of pointless. Like, this is just, none of this is very important. Well, this one is kind of important because it checks whether the text is blank. But other than that, it's just boilerplate. And with Java 14, we finally don't need that anymore. We can do this. We can have compact form. That's that. So what's a record? A record is like a class, but this defines the fields. You get the accessors for free. You get a constructor for free. In this case, I'm going to do a couple more things before construction, but that's fair game. You get equals and hash code and toString for free. You get all of them for free. What you give up is encapsulation, because essentially everything you list up here will become publicly accessible with an accessor, which is called text as well. It's not called getText, it's called text. And you can't have additional fields. So you cannot do this. This doesn't work in records. But it's still mostly a class. You can still provide additional code for construction. You can still have methods and static factories. We can see a slug here, which implements an interface. And as before, let me just show you the final version, which is this one. So now it's a record, but it can still implement an interface. So you have lots of class building tools still available. OK, now for 14, Let's run this one last time. So first of all, performance usually improves towards the newer versions. So we should see something again which is close to Java 8, which we don't on my machine apparently. So I'm angry at that. This is really bad. This is like, what, 300 milliseconds slower than the initial runtime on Java 8, but I'm sure one of these is a fluke. Cross fingers. But also, we dropped a quarter of the code base. And most of that is from records, but we've seen that other features help with that as well. And it's not just a quarter of the code base by making everything more dense and less easy to understand. I would argue the opposite is true. The code got easier to understand because the things that we want to express could be expressed more clearly. A record is a record. Take while and drop while. Optional or. All of these express succinctly what we want to do without waste. Whereas the other ways I did it before is basically just workarounds for that. So not all code that you can remove, not every way to make code denser is good, but some of them are. And I would argue in this code base, it will be hard to find places where I make the code less readable, making it denser. Maybe with var, but other than that, I'm convinced that most of the changes improve the code base, and by making it smaller, making it easier to understand. Okay, so that was the code base. If we had time, we could look at Java 9 and at the other Java releases, because we have seen a lot of features, but we also haven't seen a lot of other features. So for most of these releases, there's still a whole slide left for all the things that we couldn't see, but we don't have time for that. So I want to go to the last slide, really. And what did we do overall? So we improved encapsulation with modules. The code got safer with processes and versions. We have to do less parsing. We saw the white space issue, all that kinds of stuff. It got more expressive. Well, it gets faster sometimes. And the JVM got a lot of new features that I couldn't show you. Multi-release jars, new GCs and optimized GCs. We can now have a packager which creates, we have a packager now that can create a native installer that looks very much like the installer you would be used on your operating system. Monitoring was easier, made more accessible. And there are a bunch of new things that I hope after the session will make you want to upgrade to Java 14. First time I'm breathing, I think, during this talk. Thank you very much for being here, and I had a good time. Thanks.